Hey guys, Alex here from Deep Cycle Power. In this video I want to go in a deep overview on the latest changes that I have done to the PCB. There have been a lot of changes during the past weeks to get the Megacell charger to the next level and to be able to use it as a professional tool. So this is the PCB now. Let me get into what's changed. I will go in a full overview on everything that has changed. So the original version of the Megacell charger used the TP4056 ICs for charging, which were placed here. We had one IC that was populated on the board, and we had room for another one because we were thinking that we can upgrade the device to 2 amp charging. But then I realized that I cannot actually set the current for charging, so you will have to do hardware changes, end up with having lots of versions of the PCB, and that was not very nice to have. Like, if you want to charge a cell with 500 milliamps, or if you want to charge another one with 4 amps, you should have the same device capable of doing that and be able to set it in software like the charging current, like you do with the discharge. Okay, so this new IC, it's a BQ. Let's get in it. This is the 3D view. So it's a BQ IC BQ24195. It's called. It's a single cell charge manager, and it can do a lot of things, from setting the voltage from 3.5 volts to 4.4 volts, to setting current from 100 milliamps to 4.5 amps. And we decided to go with the 4.5 amps, and we'll try to do something, either a warning placed on the manual or in the software when you're going to set the charging current, because if you're setting 4 amps on a cell that it's not made for that, it can get hot very quick. But hopefully having the extra temperature sensors adding on the board will prevent this thing from happening, from getting the cell overcharged and overheated. So this external temp sensors that's placed right next to the sensor that we're using in the software, it's connected directly to the BQ IC right here. So if you're hitting the board, or if the cell is hitting the board, the BQ will stop charging immediately, and it's very sensitive. If you blow hot air over it, it will start blinking. The LED, which is the green LED for charging, will start blinking with a frequency of 1 hertz. So once a second it will blink and tell you that there's an error. Okay, so this IC requires a small, what is it called, a small coil placed right next to it, because it's transforming the voltage to the required voltage for charging. So it's not just feeding the voltage from the main power supply, it's actually a small transformer in there to get the right voltage that you need, and the current as well. So this one allowed us to do the following things, like set the variable current, set the charging voltage that will follow the nice curve for charging. It will start with constant current, and after it gets to the threshold, it will start with constant voltage, and that will follow a nice curve for charging and making sure the cell is topped up. And the other thing that it allowed us to do is to be able to change the input voltage from 5 volts to 16 volts. And I think that will solve a lot of issues that people were having with providing the right power to the device, because you had to have a powerful 5 volts power supply, and those can get hit if they're 20 amps. With the 20 amps with no fan, I had some issues as well. I had to put them on a side, or put a small fan on them if you're running them 24/7 and fully charging. So yeah, the new version will have from 5 volts to 16 volts. I just tested with the 12 volts power supply that I had, 100 amps power supply. It was working fine, but to do that I also had to do another change, and that's on the back of the PCB, because we still need 5 volts for the ESP, and I had to add another circuit on the back that will transform whatever voltage you're inputting from 5 volts to 16 volts. It will transform to 5 volts. So this is what this IC right here is doing. It also has its own coil. The L2 is a coil. And on the back you can see another ESP. That's for future. We'll leave it unpopulated for now because software is not compatible with ESP32, but we're planning to develop for it, and Martin said that he already has some parts of the software that are compiling file for ESP32. So maybe in a few weeks after we release this, we might have a version for ESP32. But I think for another year or so we'll keep it with the other ESP 8622, because we were planning to add more functionalities to ESP. So to make this change worth it, we have to add multiple changes to the Megacell charger, like having an external bigger display, or having Ethernet port directly connected onto the board. Because now I have on the commercial case I'm building, I have Ethernet, but I am still using a wireless module that's inside the case to communicate directly with the ESP. So it's like a small router. Actually, it's an access point that connects to your network with the Ethernet port, and then it's set up to connect to the Megacell charger directly. So it's an access point. It works fine because it's in close range. There's no other issues with disconnecting or something like that. But having an Ethernet port added to the board, it's going to make it easier to scale for the bigger commercial setups that factories might have, or DIYers, expert DIYers I should call them, if they have more than a couple of these devices, they are serious about testing batteries. So let me finish with the front, because I diverged in getting onto the back. Let me see what else I changed here. I actually added another component for mixing the signal for temperature sensors. So before we had just the onboard sensors, and I had a few requests over the past years from various clients that they would like to connect a temperature sensors outside. So they want to charge their batteries with the external extensions that we're providing, but we had no easy way to connecting temperature sensor. Basically, we had to remove the existing one. The temperature sensors is placed here. They are very small pads, so like you can see this is like the size, or even small. They have very small pads, and you had to put wires on them and extend it. It could be done, but it's an ugly mode, and it's if you want to use the slots after that, you won't be able to use the temperature sensors on board. So we had to have a more elegant approach to make this useful for future versions. So basically I added another component for muxing the signal from temperature sensors, and now we have a switch right here next to the USB. In U11 it's the USB port, and right here we have the temp switch, which will actually transform the also the voltage reading from onboard to accessory 4-wire voltage reading. So we have one mux here that have been added and one on the back. Right here the U3, it's also a mux that's used for voltage. So that will connect all the voltage measurement for the 4-wire to this pads right here, which will be soldered to the XS12 connector with 6 pins. So we'll have the 2 pins from the battery and another 2 pins for voltage reading and temperature reading. So every cell has these connectors right here, and that's also a major improvement that will allow to extend the usage of the Megacell charger. Now that you can charge and discharge with more amps, and also I also changed. There's no major change on the discharging. I just found better resistors that can handle the more current and dissipate the heat into the power plane, and also have 5 of them installed to match the 3 amps discharge that we added on this board. Okay, so I covered the ESP and the muxes. Let's see what else changed. Right here it's a hole for the antenna of the ESP, because it will be placed on the back, ESP32. So it will be placed on the back, and it will be punching easier through the board if there's a hole, or actually we can cover that with epoxy, or just don't add any traces on there so it doesn't create any interference with that. All right. What else? Okay, these connectors right here. These are for fans, so I added SMD connectors for the fans as well. It will be able, the factory will be able to place either of them, but we'll go with the SMD because they are easier to assemble, not requiring through-hole soldering after that. And these connectors right here, these T connectors, will be used for external LEDs for the commercial case. So let me show you what I'm talking about. On the commercial case, there will be, like, this is the place for the PCB, and it will have LEDs on top, which will allow to know the status of charging and discharging. And let me show you that board as well. Yeah, this is it. So it has this IC right here, which allow controlling the LEDs via I2C. So it can blink, turn them on or off. So with every process that we're doing, we can set cell 1 to start blinking for charging, for example. So we can set the frequency to 1 Hertz to blink with the green LEDs to show you that's charging, and then after that we pardon me. After that, when it's charged, we can have the LED stay green, that's charged, so it will allow us for more flexibility for controlling the LEDs. Because on the on the main board we don't have control for LEDs separately. The charging IC now controls the green LED. When it's charging, it just turns on. When there's any error with the temperature, it will flicker with 1 Hertz. And if there are any other errors, like communication errors or something like that, it will blink faster, like I don't know, 5 times per second or something like that. I saw it blinking faster. It's all written in the data sheet of that IC, but the most useful ones will be for charging. It will be turned on, and for over temperature, it will blink with 1 Hertz. So this board, I will have 2 of them, one for the 1 to 8 cells and one for the 9 to 16, which is going on the bottom row. I have added an address switch to this board to be able to switch and know in software which is which board will control the top LEDs and which board will control the bottom ones. So I'm going to produce these now as a prototype as well, and in the next week or so this should be ready as well. And the new PCB for the final Megacell charger. I think it's going to be final change now, because I added pretty much everything that we had in mind. At first I was thinking that there would be a small change to the PCB, just adding 4 layers and making the connections better for the voltage reading and current reading, because I have matched length wires driven there. I cannot show the inside layers for safety reasons, safety of not having this board copied very easy, because there are a few out there which reverse engineered. One of them actually wrote me, and he said that he can provide me some feedback. I gave him his number, but he did not add me. But basically what he did, he reverse engineered the board to know the connections, which is not a big thing, because you can put the multimeters and find where each pin goes. It's a lot of labor, because it takes time to find all the connections and make it right. But basically he was saying that he measured the discharge resistors, and some of them had different resistance, like a few milliohms difference, and he wanted to add that in the software, but that doesn't actually matter, because we're not measuring the current, we're not measuring the discharging based on what values those resistors have. So like if they are 5 ohms resistors, we don't care for that in the software. We care for what the charging IC, which is INA 219. This charging IC uses a precision resistor right here, which is called the shunt, and it's reading the current that's dropping over that shunt, and that will give us the value we need. So if the resistors are discharging with a few more milliohms, it will be read by that shunt, and that's milliamps I wanted to say. If the resistor are going to discharge the cell higher, like a few milliamps higher than the cell 2, for example, it will be read by the INA. And if there's any power loss on the on this MOSFET that turns on and off the discharging, that will be read as well. So every loss in in heat or other traces that are here are being read by the IC that's measuring the current and the voltage as well. So yeah, that was the only thing that he mentioned that he did to, and he claimed that he has the most accurate Megacell charger. I don't mind having people poking around with the board. I would mind if he tries to reproduce it and sell it and, I don't know, use the software. The board you can reproduce, but using our software, it will be prohibited to install it on a new board. You'll have some challenges to do that anyway, but yeah, that's what I wanted to say about safety and why I'm not showing the inside layers of this PCB. If you want to see them, you'll have to polish it with some sandpaper and you'll get there. Okay, so anything else? I think that will be it for the changes. I covered everything that we changed, and I'm looking forward to see this board manufactured. I have added some test point on the ESP32, so people that want to develop this, they will be able to swap the ESP16 from the front and put an ESP32 on the back if they want to play with the ESP. I'm thinking that in the future we might make a version of the firmware that has some of the API and some code that you can access easy, or I don't know. There are a lot of things that can be done, but I'm most interested in what people would use, because if there's no one interested in programming this and properly programming it, not just playing around with charging and discharging, like adding some functionalities, some software, some web interface maybe to control this easier, then there's no reason for us to go that route, because it takes our time, and if it's not in the benefit of the project, we can do other things that can increase the popularity of this board. And by the way, about the popularity, if you're watching this video and you're not subscribed, I will start doing this, because I did not do it in the past, and our channel is like 640 subscribers at the moment, and I'm planning to amp that up. So if you are watching this and you're not a subscriber, and you are on this topic on charging batteries, discharging, testing, everything else, please subscribe, because I'm going to add more videos in the future about this topic, not just about Megacell charger. I'm planning to do a small series about repairing batteries, my workflow for building a battery. I also work on a small project, not very small, but it's a project for building a hybrid car by transforming the one second. Hello? Sorry guys for the waiting. It was the FedEx company. I'm having some issues with the account. Some payments did not register, and I had to take this call. So sorry for waiting. I was saying that I'm working on a project related to batteries, and that's a hybrid car. I will give you more information later, because that's another video on its own. And just subscribe. Just click that subscribe button, and you will see that you won't regret to be there. So NT, I actually discovered some NT. What is this? Ah, okay, it's the net. Let me hide that actually. I saw there are some there are some text that I don't want them there. Let's see how I can actually hide this. All right, let's get this webcam. All right, that's better. And let's see. Okay. So subscribe to this channel, the Cell Doctor. You'll get a lot of information about testing batteries, how to build batteries, and how to use the Megacell charger. That's an important tool that is going to help you save a lot of time. Printing labels, saving the cells in the database, having control over everything you have to control when you're charging and discharging the cells, monitoring the temperature, monitoring the charts for the charging and discharging that you have available in the software, the Megacell monitor. So yeah, I think these new changes is going to transform the way people are testing cells right now, with all the new updates that we're doing, hardware and software, being able to combine the slots together to discharge. You will be able to use the entire device for one discharge. So if you have some 200 amps cell, you will have the perfect device to discharge with 3 amps per cell at discharge. That's how much? 30. That's 50 amps of discharge power if you're using all the cells. That's a lot of power to discharge a cell. It will be 4 hours to test it. Then you can test the temperature and test everything you have to know about that. You also have the power to charge it at about the same rate or higher even. The only limit, it will be the power supply that you're using, the current that can give. But for 12 volts, there are some powerful power supplies there from mining equipment, especially. Also from computers, you can use the 12 volts rails from your computer power supply directly, so not just the 5 volts one. You plug in the 12 volts. The amperage will get lower because it's higher voltage. So yeah, that's going to be a nice tool to use, and I look forward to use it as well. I did a small test to check with the 12 volts, and it was nice because it's running much cooler. The power supply runs much cooler than the 5 volts one, because it's not just the same type of current. It's less than half of that, so it's easier on the wires to deliver the power because the voltage is higher. Alright, so I will wrap up this video. I hope you enjoy it. Let me know if I should do more of this. I prefer doing streaming like this because I don't have to edit the videos. Downside is that they can be quite long, but I will try to keep them as compact as possible and show you when the work is done, because there's no point in showing you how I trace every single wire here and all that. I will just show you the final product, the test results, to keep this to the point, because it's not an Altium Designer tutorial. It's what I did with Altium Designer and change this PCB, make sure that everything runs fine. So to make sure that this board has no issues, we do the run this. We check for the rules that are created to check for clearances, short circuits, and all that stuff. So thank you very much for watching, guys. Go to deepcyclepower.com and get your pre-order before it's too late, I will say, because we have just a few spots, I will say, left in the pre-order process. There are 22 at the moment, 22 pre-orders. We're waiting for another 8, and we'll close the pre-order. After that, we won't be able to place any pre-orders. You will have to wait until we get these boards, and after that, we'll create another batch that will be priced differently. It won't be 197. I will have to check how much work is to do the connectors, and what will be the cost of the ICs in production, because these new ICs are much more expensive than the TP4056 that we used before. So I'm thinking that about 300 or 320 euros it will be for this device. From my point of view, it's worth it because it's going to give you much more flexibility, but I would prefer paying 197 in a pre-order if you're asking me. I'm not going to run with the money, go in a vacation or something like that. I will give you the devices, I promise, and I will also try to add some accessories to help you play with this tool, because that's why I'm doing the pre-order, to get it in hands of some people. Wait 1 or 2 weeks until we get the feedback from them, make sure everything works fine, and after that we start with a larger order. So if you're saying that you don't want to be a guinea pig, you're not a guinea pig, because I tested this. I am the guinea pig. This is the 5th version of the board. I have a few right here as well. So this is one without the small, where is it? So there is no switch right there, and there's another one right here which has the switch. So this is another version where I tested with the 2 MOXes right here, where I tested that this temperature sensor is going to display the temperature properly. So I'm not selling you something I did not test. I tested everything, but to make sure that we're not screwing something up, we're making a small batch first, and after that we'll go into a larger production. I think I made this video quite long, but I hope I covered all the information you should know when you're thinking about getting such a device for testing cells, or if you're looking to learn more about the testing procedures and what the hardware capabilities and software are for such device. Have a great day, guys, and I hope we'll see you around.